Hello guys, can you hear me? Let me see. The internet connection had some issues, so I had to move on to here. Let me just update the links because the previous one didn't work. I know that it might take some time from people to find out this new link. I don't know why, but the previous my internet has some issues. I tried to start the stream on the other link, but it didn't work. Okay, let's talk in the meantime before everyone else join as well. How are you guys doing? Okay, I updated it here. Thank you, man. Let me also send the link in the Telegram channel. Okay, this is some difficulty because the link has changed. The previous stream had issues. So, guys, as you know, we're gonna have Repovive contest this Sunday, hopefully. I hope that you will like it. I'm sending the message in Telegram as well. So, good, thanks. Let me bring screen. I was watching the previous subject stream on DP, and for each problem, it took me about 6 hours to learn it. Is it normal, or I'm missing something? Yeah, you can see that I talk usually about what you need to know before every stream. And if there's something that we talk about and we pass over it and we haven't talked about, we haven't talked about it in this stream, then it means that that was a requirement to know before watching this stream. For example, for this stream, the only thing that you need to know is to how to input graphs, how to work with graphs that we talked in the first graph theory topic stream, and what DP is, which we have covered it in the first DP topic stream. And yeah, that's basically all. You should just know what they are, and that's it. I mean, from any rating, even if you are newbie right now, but you know what a graph is, how to input a graph, and what DP is enough. I mean, if you don't know what DP is, also you will learn right now what DP is, but it's better if you know. Tomorrow is the local phase of Olympiad in informatics in my country. That's awesome. Where are you from? Uh, we're gonna basically, you're gonna see it now. We're gonna start with first more on trees, and then if we get to it, we're gonna talk about DP on DAGs as well. But let's see. Let's see if we can get to DAGs as well. First, we're gonna talk about DP on trees, subtrees. We're gonna go over the roadmap that we have. Let me bring the roadmap. I'm gonna use that roadmap to explain everything because we have already. That really helps to go over it in the structure. If you want to see the full roadmap, you can also go and see it there. Okay. Romania. Nice. Awesome. Is the first phase programming or theory in your country? Second stage of Olympiad in 2 weeks. Which country you are in? To get good at algorithms, did you have any background in math back then? I knew just the school math, what we taught in school, but I started in high school. We started in high school. It was 10 years ago or so. More than 10 years now, 2025. Have you lost weight? I might. I might have lost weight. Yeah, because I didn't eat enough. As you can see, I was working too much that I couldn't do anything. There are many things that I should also go to a barber shop now, but I couldn't do that because I was so busy every day. So yeah, there's a lot that I should do. I think people have joined now, and we can probably start. Uh, let me let's just start talking about it. Guys, as I said, first we're gonna go over trees, DP on trees. And I'm gonna first talk about it. Yeah, I mean, we will move on to advanced graphs as well. Also, guys, I want to know which ones of you, how many of you are studying for Olympiads and how many of you are studying for job interviews? I want to know more about what you're trying to do. I'm in ninth grade, I'm a specialty. Is it okay for my age? Yeah, I mean, when I was in ninth grade, yeah. I started in ninth grade as well. I started back then. And I was newbie too. In the ninth grade, I went from newbie to expert. Your old studio was pretty awesome. Great. You haven't seen my new studio yet too, because I was always streaming in the university. I didn't have time to do it there. I was always in school. Olympiad, job interviews. Are these things really useful in interviews? Yeah, I mean, well, when it gets more advanced, no, it's more for Olympiads. But this one, because it's the starting one, it's useful too. We have problems from lead code too. And yeah, this one is used in interviews. But when it gets more advanced, I think in the interviews, they don't ask you those advanced things. For example, it's definitely a plus that if you know them, but I don't think they will ask. Bro, where do you live and from which university are you graduate from? I'm not graduated yet. I'm in University of Maryland in the US. Grade bronze in Iowa in 1 year is hard, but probably possible. I don't know. It depends on how much you work. I don't know what's the rating that you should reach to get bronze. Maybe candidate master might be enough to get bronze medal. It's possible. I mean, it depends. I can say that I achieved candidate master in a bit more than a year. If you're asking me, yes, I got national gold medal, and as you can see in the vlogs, we got bronze medal in ICPC North America Championship as well. Okay, so let's start talking about the problems. What country are you from? I'm from Iran. Yeah, but if you ask where do I live in the US. I'm studying in the US. So let's start talking about it finally. Okay, I know that a lot of you are waiting for me to start, and I think that people have joined. Anyone who wanted to join? So I think we can start. Well, you asked the question that I cannot skip responding. How is the situation in Iran right now? It's really bad. You know, there are a bunch of murderers, fascist murderers in Iran who are ruling, who are killing people. 50,000 people are died in 2 days in Iran. Just pray for Iran, pray that we can get rid of this regime who is living there. They're horrible. I mean, they're the worst type of human being possible. So pray for Iran so that we can get rid of these people and we can make Iran free. Yeah, thanks. Thanks. Okay, so now let's start. So we're gonna first start talking about the trees and doing DP on trees. So guys, as you know, a graph or even a tree is just a bunch of nodes and edges. I'm gonna start from a very beginning, but we're gonna go over this fast. We know that one of the ideas that helps really helps us, especially in trees. One thing that really helps us to give some structure to trees is to have a vertex as a root. So we know that a tree might be very messy without a root. The point is that to give it some structure so that we can solve problems, we usually pick one vertex as a root. Sometimes we just arbitrarily choose this vertex. I mean, we, for example, choose vertex 1 as the root. Arbitrarily, we choose some vertex. Sometimes we think to choose which of the vertices as the roots. But the main idea is that we choose the roots to give some structure to our tree, because otherwise things will be messy, and it is necessary to do DP on trees, to choose some roots for the tree. And there's also an idea that is rerouting the tree. So it's basically when you have a root, you will try to move this root along the along the tree, in order to solve a problem for different vertices. I have already made some videos for DP rerouting idea that we solve a problem with rerouting. For example, Word Eater Brothers. If you search in YouTube or in Google, you can find that video or go through the channel. So that's basically the first thing that you should know. Thank you. Thank you very much for that. No, this lesson does not require any knowledge of DP. I mean, but you should know how to store graphs and trees, because we're not gonna cover it in this stream. We're gonna go over the next level. If you don't know that, you should first see the first topic stream on graph. Is rerouting hard? No. I mean, once you know what it is, no, it's not gonna be hard. We're gonna go over it as well. So that's the first thing that you should know. That's what rerouting is. And guys, again, if you want to at the same time read from the text as well, you can use this. This stream is gonna start from the beginning. We're gonna go fast over that, and then it's gonna go over more advanced topics. Yeah, after so many days. That's right. Yeah, I'm glad. So, yeah, I mean, that's basically what we want to do. I'm going to start with a very simple problem now. I'm going to skip this for now. You can read them. The live stream skips some of the units. If you want to read all of them, you can go and read them in text. But because we have a limited time, we're going to go over the main points and go over them. I'm going to very quickly talk about a very simple problem that was from LeetCodes that says that you are given a tree and you have to find the maximum depth in it. It's a problem from LeetCodes. You are given a tree and you have to find the max depth. From the roots, you want to go find all the vertices. Well, we know that in such a because I know that most of you already know how this will be solved, I'm going to go over it very quickly. If you had any issues, let me know. If you wanted me to talk about it in more details. But basically, the point is that you can start from the roots and you can store just some value like h. that shows that what is the height of vertex V. Height of roots will be 0, and from each vertex you can update the height of its children. Height of children of V are gonna be height of U. Height of U is gonna be height of V plus 1. And this way, height of all the vertices will be calculated, and at the end you can just output the maximum of all heights. It is the most simple DP on tree that we have. We calculate these values of H, and these values are helping each other to be calculated. So this is the simplest form of DP that we can have on a tree. As I said, I went through it very fast because I believe that most of you already know about this. If you need more explanation on that, let me know. Or you can also read the text. So we can, I'm not very online on Discord, but we're gonna get more online Discord soon. Is it diameter? No, this is not yet diameter, but I'm gonna talk about diameter soon. There's a problem from diameter that we're gonna go over it. Will you green for LGM? Probably not. I mean, I don't have much time yet to do that. I'm studying right now for PhD. I'm also working full time on Repovive, and this is something that makes it hard. I mean, it's not my priority, but maybe someday if I can find some free time, we'll do that. So now I'm gonna go over a problem that is a bit more complicated. It's the next level. The problem is from CSES. This problem. How you write on Chrome? I use something that I can write on anywhere. You know, this is the app iPevo in it's for Mac. I don't know if it's for Windows as well or not. Yeah, so anyway, the next problem says that you have a company with N employees. And each employee except the boss has one direct manager. Guys, when we see things like this, we can instantly see that this is completely a rooted tree. That you have many employees and each employee has a direct manager. It means that that's basically the parent of this vertex in the tree. So it's like we have a vertex tree. For each vertex tree, we have a parent. If completely a rooted tree, for example, this is the manager of all. These are the people who their direct manager is this one, and each of them again have some people who are the manager. This one is the manager of them, and so on. So when you see something like this, you can quickly think about that, okay, this is just a tree. You have to find for each person, you have to see that how many subordinates does this person have. And this is a problem that is basically a subtree size in a tree. I mean, if you accept that, if you realize that, once you realize that, what we have in this company is basically a tree hierarchy, that we have a manager that some people work under his management, and then each of those are manager of a few people, and so on. This question basically is asking that for each vertex V, find out what is the size of the subtree of that vertex. What does subtree mean? The subtree means the number of vertices below that vertex. Again, for these parts, I'm going through them fast. If you want me to talk about any parts in more detail, let me know, because we're gonna go over more advanced things. If you want more explanation on anything, let me know. So we have these subtrees. Basically, we want to calculate that what is the size of the subtree for each vertex. Now, guys, the point is that when you want to calculate the size of the subtrees, the size of each subtree will be equal to the sum of the size of the subtrees of its children plus 1. For example, you want to calculate the size of this subtree. You know that you can start a DP from the leaves. What do I mean by it? I mean that for each leaf, I start from leaves. I start a DFS, I go down. I say that, okay, for example, the size of this one is 1 because there's nothing below it. The size of this one is also 1. The size of this one is also 1. For this one also, I initially set its size to 1, but then I will go over all the children of this vertex and add the size of those subtrees to this subtree, because whatever that is in those subtrees is in this subtree as well. So 3 times I'm going to add 1 to it. So the size of this one is going to be 4. And then I'm going to come here in my DFS. I'm going to make it 1, make this 1, make this 1. This is going to be 3. This is going to be 1 plus 3 plus 1 is going to be 5. This is going to be 1. This is going to be 5 plus 1, which is 7. This is going to be 1. This is going to be 1. This is going to be 1 plus 1, which is 3. And this is going to be 4 plus 7 plus 3 plus 1, which is going to be 15. This way, the size of the subtrees of all the vertices will be calculated. And at the end, I can output the size of the subtrees. That's, again, another very simple version of DP on tree that you can basically use. That's basically can show you that what is how DP on tree works. If it's clear, guys, please use this emoji or put a plus. If it's not, let me know. Is my question ignored? I don't know. If this is the question, I answer. I don't know if you asked another question as well. Can you send the problems you are going to explain? I can send it, yeah. I mean, it just takes some time. If you want, I can go over it and send the link of the problems. Can we do it iteratively somehow? Well, if there is some structure in the tree, for example, always the ID of the parents are less than the ID of the children, you can do that with a 4. Because you know that the vertices with greater indices are going to be the children of vertices with lower indices. But otherwise, if there's no structure, not necessarily. Okay, so I think this is also okay. So we're gonna pass on to the next problem. The next problem, guys, and guys, if you want to know the problems, you can also take a look at this section as well. And you can see many of the problems that we're gonna go over. So this problem says that we are given, I don't know why I don't have the link of it. Okay, this one doesn't have the link. I should search. I don't know. We forgot to place the link. This problem says that you want to calculate the diameter of a binary tree. So you are given the root of a binary tree. You want to find the length of the diameter of this tree. What is the diameter? Diameter is the distance between the two farthest vertices. Is this statement clear? I'm not going to cover this whole graph section. I'm going to talk about several sections. We're going to go over other sections as well. That I mean, I compiled a set of problems, a set of parts that is relevant to DP on tree and DP on graph. No, this is different to max depth. Why? Because max depth is finding the maximum distance of a vertex from the roots. That's the max depth. But in this problem, you don't want to find the farthest vertex from the roots. You want to find the two farthest vertices. So both of them can be anywhere. For example, the distance can be from this vertex to this vertex. In max depth, one side should be the root. In this version, these two vertices can be anywhere, and we just calculate the distance between them. So that's the difference that it has to max depth. So we want to find two vertices with maximum distance, and we have a binary tree. Okay, so now we want to find out that how we can do this with DP. This problem has a more general way, that is a tree diameter, that you are given a tree, a normal tree, and you want to find the maximum distance between two nodes. The difference between these two problems and why this one is easier is that in this one we have a binary tree, not a normal tree. So it is more limited and it's going to make it easier. What is a binary tree? A binary tree is a tree that has two children for each vertex. So you want to find out that what is the distance between the two farthest nodes. The idea in the idea in this problem is going to be this way. For each vertex, I will try to find the farthest node that exists in its subtree. So we basically want that for each node, find out basically the max depth that exists in that subtree. We see that if I start from this vertex and keep going down, how much I can go down. So I can have something like, define something like, I can name it dp. I mean, dp is just a name. dp of v means that what is the distance from this vertex v to the farthest node in the subtree of vertex v. So that's what dp of v means. From vertex v to the farthest node in the subtree of vertex v, what is the distance? How can I calculate that? dp of v will be equal to maximum of dp of its left child plus 1 and its right child plus 1. Because whatever the farthest node is from this vertex, I can add 1 and that distance exists to this vertex. Whatever is the dp in this subtree, I can add 1 to it and its distance to this vertex. So it's going to be dp of left node, maximum of dp of left node and right node plus 1. And now that I want to calculate the diameter, I can say that, okay, we want to find the two farthest vertices, right? These two farthest vertices, there's basically a point that's, well, we call it the LCA. But if you don't know what LCA is, there's a point that both of these vertices are the subtree of that. I mean, there's a vertex that both of these vertices are subtree of that, are in the subtree of that vertex. The point is that if for each vertex, I assume that this is going to be the vertex that one of the nodes of the diameter is in one of its children and the other one is in the other child, I can say that the diameter this way is going to be the dp of left child of it plus dp of the right child of it plus these two edges. Or if we are calculating the number of vertices, it's going to be the number of vertices here plus the number of vertices here plus one vertex here. So basically, for each vertex, if I want to find that, okay, if the path is in a way that it goes through this vertex and it goes through the two children of this vertex, I can say that it's going to be dp of left node plus dp of right node plus this one vertex. And this is how I can calculate it. Is it fully clear? That's what I'm saying? Yes, it's basically this, yeah. If you want to count the number of edges, it's going to be dp of left plus dp of right plus 2. If you want to calculate the number of vertices, the base cases is going to be 1 instead of 0. And then it's going to be dp of left plus dp of right plus 1. This wouldn't work for a non-binary tree. For non-binary tree, we should extend the idea. We should improve the idea if we want to do it like this. I'm going to talk about it, how it would be in a normal tree as well. Yeah. Normal tree also has another solution too that is non-DP that we're going to talk about it as well. Maybe 2 max lists in tree. I didn't fully understand that. Guys, is it fully clear? If you have any questions about it, let me know. I want to ensure that you completely understand it before going to the next part. So if there's any issue, let me know. If anything is not clear or I talked about something very fast and you need to talk about it in more detail, let me know. Also, let me know how you feel so far. Is the topics we covered so far? I mean, are these easy for you? Are these hard for you or medium? I want to know that What is your belief? You want to go over harder problems, easier problems, keep the same pace, go slower, harder? I want to know more about how you feel about it as well, because that's what is important and what is gonna determine the way we go over everything. Harder problems, harder. Okay, so almost everyone wants to go about it harder. So we're gonna increase the pace to get to harder problems also. Okay, so it's fully clear. Awesome. So that's how it can be calculated. Now let's go over the next problem. That is the CSES problem. That is the normal tree. That is the diameter of, we want to calculate the diameter of a normal tree. How can we improve the idea that uses DP? In the roadmap, I covered another solution as well. That is a double BFS. Some of you know about it, how it works. Double BFS or double DFS, both works. But I want to talk in this topic stream, I want to talk, because it's DP on graph, I want to talk about how we can use the same DP idea to solve that when we have a normal tree. If we want to improve this solution to solve it in a normal tree, we can still have the same DP that finds out what is the distance to the farthest node in the subtree. And then now a vertex can have multiple children, not only two. It can be more. Now what I do, I iterate over these vertices and I keep the value of the maximum heights that I've seen so far over the previous children. So as I iterate, I first say that, okay, I see here what is the depth, maximum depth. I save it in maximum depth. Then when I come here to each vertex that I come, first I know that what is the maximum depth in the vertices that I've processed so far. I know that in the vertices that I've processed so far, what is the maximum depth that we have. Then I can say that, okay, if I want to match this with one of those children, I will definitely choose the one that gives me the maximum depth. So I will see that what is that max value and I add it to DP of this vertex. So I add DP of this vertex plus the max that I've seen so far plus 1 or 2, depending on you want to calculate the number of vertices or the edges. So the idea is that the only thing that changes is that I iteratively go over the children and I save a value that what was the maximum I've seen so far, and I add the DP of the current one to it. When I had two children, it was easy. I could say that this one plus this one. But when it's more, I will iteratively go over the vertices. I will calculate that what is the maximum so far. And then for each vertex, I see that, okay, what were the maximum of the previous ones, and I add this one to it. Is this also fully clear? If it's fully clear, let me no, put a plus or use the 100 emoji. And also, guys, if you are enjoying the video and if you want to support, please consider liking the video. You can come here and like the video. And if you want to support the YouTube channel, I would really appreciate it if you consider joining the channel. As you know, we started the projects that we want to cover all the contests, and we have streamers, other streamers doing a stream on our YouTube channel. And we basically definitely need to pay them because they are putting their time. We are giving money. If you want to become a streamer on the channel, also let us know. So basically, yeah, we also plan to have more people doing topic streams. Not only me, but others come do topic streams on more advanced topics, on less advanced topics for different levels. So if you can, please also consider joining the channel, being a Repovive supporter. If not, that's totally okay. Even if you give likes, that's a great support, and I really appreciate that. Could you write the recurrence relation? Yes. Rating DP on graph. I didn't fully understand that. Will you do a number theory or combinatorics topic stream? I already have them. I mean, if you take a look at the topic stream, the link is in here in the description. A lot of these topics are already covered, guys. For example, number theory. Combinatorics is also covered. Okay, so the recurrence relation. We basically have a for. I mean, if I want to show you on the code, we basically have a for. I tell you the complete thing. We have a for, and for each vertex, we first say that ans max equal to. Max equal is not a real operator, but you know what it means. Max equal to me, dp of current vertex. I don't know why my laptop became so laggy. dp of v plus mx plus 1, for example. And then, or if you are calculating the number of edges plus 2. And then I say that dp of v, or sorry, mx max equal to dp of v afterwards. Mx max equal to dp of v. This is still in the for. So we do these two things. We go over the vertices and we do these two things. First, I calculate with the previous maximum, and then I update the maximum because this one will be considered in the maximum as well. So this is how it works. I hope that it is fully clear. Do you use your mouse or writing? I use touchpad to write. The point is that I've done this for a long time. I used to teach a lot. I had a lot of students. So I got used to it, to write well. Right now I'm not writing very well because my laptop was laggy, and that causes some issues. But yeah, I mean, when it's not laggy, I write well. Okay. So touchback writing is crazy. It's insane. Yeah. You get used to it. And guys, as I said previously, in this topic stream, at some point in the topic stream, we're gonna share, either I share or other members of team will share in the live stream coupon codes that you can use for 3 months of Repovive membership. And if you have any questions about that, let us know. Our team works all time from morning to the end, to the night, and even night to the morning, to make it something that is really amazing. And I hope that you use it. I mean, you enjoy it. If you have any questions about it, let us know as well. You can read about it in here. It's basically a situation that you can be completely trained by us. I mean, we can do the planning. We can create content for you based on what you need. We can answer your questions on how the state is. So you basically do not waste your time anymore. We had to start this because we want to improve our servers. We want to work more on the prizes that we give to people on the contest and everything. And you know that to make a sustainable company, this is what you need to do. Right now, because my IP is from the US, the amounts that it shows to me is in the US. But for example, in the countries that have different financial situation, we have a special discount for those countries because of the situation that is different in those countries, and we fully understand that. We got a lot of comments about that people were mentioning that, and we said that okay, it makes sense, and we added that. You can either get the starter one that you get premium roadmaps and interview problems if you're working on interviews, or the premium and premium max that lets you be completely trained by us, and we take care of you and what you do, and prepare you for exactly the jobs that our partners are looking for. If you want, we'll talk more about that. Let us know if you have any questions. And guys, this way you actually help Repovive to grow as a company as well. When you know the situation in Repovive, I mean, in the past month we had to spend like $2,000, even over $2,000. We need to make it sustainable, and you are actually this way help us to make Repovive sustainable as well. I'm gonna share the coupon code a bit later in the stream. And I hope that the ones of you who have already got the subscription have enjoyed it so far. And definitely don't hesitate to reach out to us if there's anything that you want to mention. If you have premium, you are already in contact with one of our members. If you are a starter, you can also let us know in any places that you want. Either on Repovive, you can message us, or anywhere else. Basically find two highest values. Am I right? In the okay, so it's in the binary tree, yes, it's the two highest values. I mean, the okay. If you want the two highest value, I mean, yeah, when we have multiple children, also, yeah, we will find the two highest ones. Once we are iterating, we are calculating the maximum of the first one that we have, and for the other one, we just say that, okay, assume that if this one is the other maximum, what is going to be the other thing that will match for it? But yeah, basically what we are doing is finding the two highest maximums. There is one program where you can remove one vertex and add one vertex on tree, and you need to find max diameter. Is it possible to solve it with DP? Send a link of the problem so that I can see what exactly you need to do for that. I mean, is it queries that you will remove problems and remove and add vertices, or is it once? Okay, let's move on to the next problem. Next, we're gonna go over Subtree DPs. It's in section 8. And guys, thank you very much for the guys who gives us reports about the issues. Many of them are resolved. Some of them we haven't updated in here. We have resolved them too. Thank you for giving us feedbacks on the roadmaps. And if you like a roadmap, also give a like to it. For example, this one got 70 likes, which is really great. So that we know that how people like it. I mean, this has no effect on anything. It's not like on YouTube. Likes on YouTube actually help us to get discovered by more people. But in here, we use it for ourselves to know that's how you like the roadmap. So let's move on to the next thing. We're going to talk more about the Subtree DP. There's an issue in here that we're going to fix after the topic stream. So Subtree DP basically processes trees from leaves to roots, and we basically go over the subtrees. We want to calculate something in the subtrees. That's actually the main idea that Subtree DP has. We solved one problem just now in this topic stream, that you just had to calculate the size of the subtrees. Let me ensure that I'm on the right screen. Yeah. Where you had to calculate the size of subtrees. That was the easiest version of Subtree DP, that you could calculate the size of the subtrees. But there are some more advanced problems on Subtree DPs. We go over many problems in the roadmap itself. I'm going to talk about some of them here and explain them to you. Hopefully, we will soon start covering videos and make videos for them as well, other than live streams. But yeah, that is basically what we are going to go over. Let me see. Okay. Okay, so let's talk about the first problem. And we have some examples that you can go over them as well before talking about the problems. Let's start with the first problem that we have. It says that given the structure of this is basically what we saw previously. That was like, given the structure of a company, your task is to calculate for each employee the number of their subordinates. That's what we just covered. You just calculate the size of the subtrees. That's going to be all that we had in this one. Next, we have a problem, the house robber 3, that we're going to talk about it. For some reason, the link is missing in this one as well. I'm going to add the link after the topic stream. This problem says that we have a thief that wants to rob a tree that we have, and the tree is rooted. And basically, it cannot rob two adjacent nodes. We know that each node has some money. This one cannot rob two adjacent nodes. You have to say that what is the maximum that it can rob, the maximum value it can rob. We had the link on this one. I judged it wrongly. So basically, now we need to just find out that what is the maximum money that we can rob if we cannot rob two adjacent vertices. So that's what the problem is. Is the problem statement fully clear? If there's any issue on that, let me know. Otherwise, I'm gonna talk about it. If possible, then cover Appleman problem. Yeah, we can. We can do that. Okay. We definitely, I think one thing that we can really help the stream is that we do the suggestions of use. So, okay, definitely we will do that one. So basically, we want to find out that what is the best value that we can. This is a very good example of Subtree DP. What we want to do is that instead of solving the problem once, guys, DP is mainly defining some sub-problems such that instead of solving a problem as a whole, we define so many sub-problems and solve all of them. So that's what means that we make more work for ourselves. We have to solve one problem, but instead we define so many problems and decide to solve all of them instead of solving that one problem. But why do we do that? The reason is that these sub-problems help each other to be solved. You can see it exactly in this problem, how we approach it. It tells you that if we want to rob this tree, what is the maximum money we can get? Instead of solving this problem, what we do will be to solve it for each subtree. For each subtree, for each vertex V, I see all the vertices below V, and I say that, okay, if we wanted to rob only this subtree, what was the answer? If I wanted to rob only this subtree, I call it DP of V, and not only that, I break this into two subtrees as well. I consider two cases. DP of V and 0 means that what is the maximum value that we can rob if we don't rob the vertex V itself. DP of V and 1 means that what is the maximum we can rob if we rob the vertex V itself too. So we have two cases. If we want to rob the subtree of vertex V, if we rob V2, if we also rob vertex V itself, or if we do not rob vertex V itself. So instead of solving one problem, we are actually forcing ourselves to solve two n problems instead of one problem. But we will see that why we do that, why we actually force ourselves to do more than required, and how these problems help each other to be solved. In this problem, we can just run DFS and go down and start from the leaves, trying to calculate the answer for the leaves. For a leaf, for a vertex that has no children, the answer dp of v and 0 is going to be 0 because nothing will be rubbed. dp of v and 1 will be the value of that node. And then for all the other vertices that have some children, there are two cases. Either we rub vertex C or we do not rub vertex C. First, let's calculate the case where we do not rub vertex V, dp of v and 0. dp of v and 0 means that v is not going to be rubbed. So the children of v can be rubbed. So for each node, I have to add maximum of, for each node like u, I will add maximum of, or let's name them u1 to uk, the k children that we have. dp of v and 0 basically is going to be sum of dp's of u and 1 maximum of dp of u and 1 and u and 0. Because each ui can either be rubbed or not be rubbed. Both is possible because v is not going to be rubbed. V is not going to be rubbed. So it's going to be okay if ui's are going to be rubbed. So we have both of the cases. Whatever that was giving us more value, we will choose that. So it's going to be the sum of max of dp of ui and 1 and ui and 0. And dp of v and 1 is going to be equal to, first of all, the value of v itself, because v is going to be rubbed. So we should have value of v. Plus sum of, now the children of v should not be rubbed, because v is going to be rubbed. So if the children will be rubbed too, we're going to have two adjacent vertices that are rubbed. So it's going to be sum of dp of u and ui and 0. This is how easily these dp's can be updated. And you can see how these problems help each other to be solved. That is why instead of one problem, we are solving two n problems. While we care about only one of them, at the end, we should just see out maximum of dp of root and 0 and dp of root and 1. So only we need two of these values at the end. But we define two n problems and solve all of them. Why? Because they help each other to be solved. And you see that how cleanly you can calculate all of these values using each other. Is it clear or not? If it's clear, please use the 100 emoji or put a plus in the chat. Can we start from random node? Yeah, you can. In this problem, you can pick any vertex as the root arbitrarily, because we just choose a root for structure. That's an example of using root for structure. Awesome. And thank you for the hearts, guys. I really appreciate that. Is there a general technique to prove some DP transitions are correct, similar to exchange arguments for greedy? Well, the point is that the difference that we have in greedy and the difference between greedy and DP is that in greedy, we choose a specific way and we show that that way is optimal. We prove that it's optimal. For example, with exchange arguments. But in DP, we are considering all the cases. DP is a structured way to consider all the cases and find the best values of them. So the difference between greedy and DP is that DP considers all the cases and finds the best answer, considering all the ways in a structured and optimized way. Greedy says that this way will work. And then we prove that why that way will work. You can look at our greedy topic stream as well. I think we have greedy topic stream. We had so many topic streams that I forgot which. Yeah, we have a greedy topic stream. You can take a look at that too in order to fully understand how difference is proving in greedy, how different it is. But in this one, we basically say that we are considering all the cases. Either V is there or V is not there. And we say that, okay, for each child, also if you see, we are considering both of the cases. And for example, when we have DP of V and 0, we are considering both of the cases. UI will be there or will not be there. And when we are calculating DP of V and 1, for each child, this time we cannot have UIs. So we have no other choice other than DP of UI and 0. So we basically are considering all the possible cases. Right? Yeah, sure. Okay. So let's move on to the next problem. I was out of the camera. What was the Appleman problem that you mentioned to cover? I think it's not in this section. Maybe it was in another section. Can you give me the full name of the problem you wanted to discuss? Yeah. If you want to discuss it, let me know and we will cover it. So if you have any questions, let me know about this. That's basically all. And this is basically a pattern that is called include-exclude pattern. So this is a well-known pattern, include-exclude pattern. How is it? It's basically we create two DP values for each node. One of them is for the case we include this vertex. One of them is for the case that we exclude this case. This is a very, very well-known pattern. And we completely talked, I mean, you can read more details in here. We completely talked about how the transition works in include-exclude patterns and everything. So that is all. Okay, Appleman and tree. I think we already covered this problem. Yeah, I mean, it's interesting. If you search Appleman and tree, you will see a video of me that I've covered this problem. Hey guys, this is Shine. This last year. So if you want, I think maybe it's more efficient if you go and watch that one. And this is the previous stream, previous studio that we had. If you want, I can talk about it again, but maybe it's efficient if you watch that one and then come back to it. If you have any other suggestions, let me know. We can talk about any other problems. Can you code this problem so that we can see how to convert these algos into working code? Yes. Do you prefer if I implement it or do you prefer if I go to the next problem? You tell me. Can you do segment tree and Fenwick topic tutorial? Yes, we definitely can do it. In the Telegram channel, guys, I had a basically poll that you can choose what the topic the stream is gonna be. And before the poll, I ask you for your questions, for your suggestions. The poll is gonna be based on the suggestions you give. So we have completely democratized it, and you can choose. That's what the topic is gonna be. Can you? Okay, I read this. Do you prefer to code this one or to move on to the next problem? It was very funny that I searched the name of the problem and the video was brought up before discussing it again. It literally told me that don't discuss it again. We can move on. Will we do DP on general graphs too? Yeah, I mean, I plan to talk about DP on DAGs as well. Do you know what DAG is? it's gonna be more advanced. So next time we can talk about DP on DAX. If you know what it is, we can start talking about it today as well. Yeah, and we talked about it in the previous topic streams. Guys, try to watch all the topic streams. That's super important because a lot of times I see a lot of passionate people that want to learn and they don't know things that we've already covered in the previous topic streams. And sometimes I have to talk about it again, which might be, for example, waste of time for the rest of the people because it's already covered and it's already mentioned. For example, on DAGs, I've already covered it either in Graph Algorithms 1 or in Graph Algorithms 2. So I really recommend to you to try to watch all of the topic streams so that when we go over the new topic streams, you know the things that we've already done. So I don't know, maybe Graph Algorithms 1, Graph Algorithms 2, try to watch all of them so you know all the basics that you need to know. I really recommend you. I mean, if you are really passionate about the topic streams and you are learning from it, I really recommend to you to build the background first and watch all the topic streams. That really helps you to fully understand and learn the new things that I teach you. And I have solved a lot of problems. It completely lets you learn everything. And we started from very basics. For example, when we talked about DP, we started from very basic DP. When we talked about graph, I talked about very basic graphs and I moved forward. So it can really help you to fully understand all of this. If the DAG is also a functional graph, you can reduce the problem to 3 problems sometimes. Well, it depends. Yeah. It depends. Sometimes, maybe. Okay, so let's move on to the next problem now. And after this problem, I'm gonna share the discount code. But guys, we have to limit the time of usage of this discount code. The discount code will be available until the end of the stream for sure, and probably 1 or 2 hours after the stream. We set it for, I think, 3 p.m. EST for the deadline of it. The discount code will be available in that time to everyone who participated in the topic stream, such that we also say a thank you for supporting and participating in the topic stream. I think because of you, I mean, if you were not in here, these topic streams wouldn't mean anything. I really am glad if you're really learning something from the topic stream and it helps you growing. Okay, let me move on to the next problem. The next problem is this one, binary is unit 831. Binary tree maximum path. This problem says that we have a binary tree and each vertex has a weight. You want to find the path in this tree such that it will have the maximum possible sum. And the vertex values can be also negative. You have to find the maximum path sum. If you understood the solutions of the problem so far, this problem is tacked hard on LeetCode, but it's not really hard. And it was in interviews of some companies. This problem was covered in some companies' interviews. So, I mean, if you know how these problems will be solved, you can actually land a job and do something valuable for a company. I mean, that's how important these things are. So let me tell you about this. If you already understood that's how we calculated the diameter in the tree, the diameter in the binary tree, you will also understand that's how this one will be solved. In the diameter in the tree, we said that first we calculated dp of v that says that what is the farthest node in the subtree of a vertex, right? We found out that what is the farthest node in the subtree of a vertex. It's like in that one, the value of each vertex was 1. We were adding 1 for each vertex. Now each vertex has its own value. So how will I change the definition of DP? I will say that DP of V is the maximum possible sum that I can get if I start from vertex V and I keep going down. Okay, so it's gonna be the maximum possible sum I can get that I start from vertex V and I keep going down. How can it be updated? Very similar to how we calculated the maximum depth in the subtree. We will say that it's going to be maximum of dp of left child and dp of right child plus the value of this vertex. Max of dp of left child and dp of right child plus value of vertex C. And once you have these values, again, we're going to be back to that LCA thing, that vertex that had both of these vertices. And for LCA, guys, if you want to know what LCA is, also, you can take a look at our previous topic streams on graph. We have talked about that too. So if you want, we will just fix the vertex that has both of these vertices in subtree, and we can say that, okay, the maximum value is going to be the dp of left child, this time plus dp of right child, plus the value of this vertex. That's all. dp of left child plus dp of right child plus this vertex. We have a global ans that we say that ans is equal to maximum of ans and this value. This way we can calculate the maximum path sum. That's how easily it can be calculated. If it's clear, please use the plus emoji, plus in chat, or this 100 emoji. This one. This again just works on binary trees, but next I'm gonna tell you that how can we do it on normal trees as well. If it's fully clear, next I'm gonna talk about how it works on normal trees as well. Awesome. So I guess there are no questions. Let me also quickly tell you that how we can do it on the normal tree as well. I want to see that if there is a problem that already covers that. We don't have such a problem. Maybe I should search more, but let's assume that instead of 2 children, each vertex could have many children instead of 2. What was the idea to solve this? Again, the same idea that I talked on the diameter case. We can just iterate over these children. For each vertex, we say that, okay, we keep the maximum. What was the maximum of DPs of the previous ones? For each one, I say that ans is max equal to DP of this one plus this mx plus the value of this vertex, and then I say mx max equal to dp of this vertex. So the same idea that we use for diameter. We can just go over vertices iteratively, and we keep updating maximum, and we will update the answer accordingly as well. Is this also fully clear? If it's fully clear, please put a plus or use this 100 emoji. Can you also do 2 BFS like in the unweighted case? In the unweighted case, it's going to be just a diameter. So yeah, I mean, diameter can be either solved with 2 BFS or 2 DFS or DP. Both works. In the weighted case, it's going to be different. We can think about it if anything other than DP can work or not. Probably with making some changes to the solution, that can be solved too. Can I start DP without tree or graph? Yeah, I mean, you can start what DP is without DP and without tree and graph. Take a look at dynamic programming number 1. I've already covered a lot of stuff. I started from the very basics of dynamic programming and go over everything. Again, guys, try to watch all the topic streams from the beginning if you want to learn. I mean, if you are actually getting values from topic streams, make sure to watch those ones as well, because that also helps that when you attend the next topic streams, you already know the previous things, so we can build on top of that and go on more advanced things, and you learn better this way. I can opt if I master DP. But it depends on what do you mean by master DP. There are some problems that are even challenging for IGMs and LGMs to solve. As someone who's an IGM, when I was participating in contests, there were some hard DP problems that were existed. So mastering is not something 0 and 1 that you say that's how I master or not. There's always room for improvement. But DP is super helpful to get to at least candidate master. In the journey to candidate master, I can say that DP is the most important topic. Does it work only for binary tree? Yeah, I just talked about it. It works for binary tree, but if we go iteratively, we can have it in normal tree as well. How many percentage of the question is solely on DP, on Codeforces? Maybe everyone can give their idea, but usually it's not just DP. Sometimes DP blends with other things. For example, you see in these problems, it's DP and graph. In some problems, it's DP with data structures. In some problems, it's DP with something else. But if I can tell you the number of problems that DP is important in them, I can say that maybe even half of the problems, if we leave easy problems aside, I can say that in the rest, it's like half of the problems are using DP. Or for example, in Iran, in National Olympiads, I remember that I was the author for a long time in National Olympiads. I was the main responsible person, basically. We had maybe out of 9 problems, 6 of them, for example, had DP in some place of them. So in Olympiads, especially, it's very important. In job interviews, it's very important as well. And in both Codeforces and Leads Code, you see a lot of such problems, DP problems. I just remember that back then when I was doing, I was preparing Olympiads, Iran Olympiads, I had an international mirror as well. I prepared an international mirror so that everyone could participate in the contest. If it is helpful, we might even consider doing that again as well. I mean, right now I'm not altering problems in Iran Olympiad anymore from when I left Iran, but we can put the best problems of Iran Olympiads out there so that everyone can see and learn from it. We have very good theoretical problems as well. That might be interesting for you. So yeah, you can, if it's interesting for you, we can add those as well. Okay, guys, let me share the discount code that I promised to share today. So let me find it. Guys, you can, for premium membership or for buying any of the roadmaps that you are interested in, you can use this discount code. With this discount code, you can get either the roadmaps or the premium memberships. Let me also show you the roadmaps, the premium roadmaps that we have. There are a lot of premium roadmaps that we are still being prepared and are right now hidden. For example, Codeforces hard problem solving. This is hidden and will be released very soon. We should do just, I mean, it's taking a bit time. We spent more than a week on it. By now, it's more than a week. We just want to release it when it has really good quality. I mean, not perfect, fully perfect, because it takes infinite time to make it fully perfect. There always will be some room for improvements. That's your feedbacks are gonna be helpful for that. But it's gonna, I think, be released in the coming 1 or 2 days. We have dynamic programming problem solving that we go in more in depth in everything. Graph problem solving, quant interview prep for people who are doing interview prep, lead code hard problem solving, Google interview prep. I know that a lot of people are interested in getting a job in Google. So we have prepared this and we put a lot of time. You can either get a roadmap, and for purchasing a roadmap, we also added a financial aid option as well. Because it's only our server, it's no human cost in it, human time in it. It's just a server, so we could give more discounts to it. We have some financial aid option that you can get 50% discount on it. And on addition on that, you can use the coupon as well. And we have the premium membership as well. If that's something that is interested for you, you can use this discount code to get the 30% discount. For premium membership, it gives you 3 months of discounts. The starter roadmap, I think, is the first one that you get access to the roadmap, the starter category, and the premiumers are when you're gonna be in touch with us to be trained by us, basically. The point is that, guys, a lot of people actually are wasting their time, wasting a huge portion of their time while practicing. I was teaching a lot during the past years. I'm still teaching, but it's now less. I teach less now. I put more time on Repovive and my studies. I see a lot of people waste a lot of time, and that's super important to know what to focus on, what not to focus on. I've already made some videos that are publicly available as well that I talked about the mistakes that people make. You can take a look at our guideline videos, like mistakes in layering competitive programming. How I went from newbie to expert in 3 months. It already got 127K views. I think that was the video that you were most interested about. And the things that you should never do to get out of newbie, and the things that you should do to get out of newbie. I talked about a lot of mistakes that people make to grow in them. But if you wanted to have more connection to the team, you can use those. And that can also help Repovive to grow faster. And we can actually bring Repovive to the next step faster. Thank you, Satyam. Thank you. That means a lot. What is your username on CF? My username is Shayan. I mean, this is my username. Try tree cutting problem. Okay. Let's talk about the next problem. Let me also write that this is the coupon code because it's a bit weird without any explanation. Okay. Let's move on to the next problem. You propose talking about tree cutting problem. Is it in this section or another section? I think it's not in this section. Can you tell me the full name of the problem? Or or otherwise we can also move on to the next problem that we have. Let me basically prepare until you want to send that. I will tell you about these important things, distinctions that exist. They are worth talking about in here. Guys, trees have no cycles, and that's very important in 3D. That's basically the main thing that we use in solving problems that are DP on trees. That's the most important thing. And there's also another type of graphs that I just talked about that are directed graphs and they don't have any cycles. So it means that they don't have any directed cycle. They are called DAG, directed acyclic graph. A directed graph that has no cycles. That's also very important. And with topological source on those type of graphs, we can actually have great DPs. 3DP is usually like we process children first and then we combine them. That's all. That's super important, guys, to understand this fully. These concepts actually help you fully understand that how actually you can solve DP problems. I hope Repovive won't get abandoned like CP project. Yeah, sure. I mean, we definitely will not abandon Repovive. So can you tell me the complete name of the problem? Tree cutting, is it on Codeforces or where? I can talk about it if you need it. Is it 1946C? Is this the problem we want to discuss? And guys, I just saw something that is worth sharing with you as well. I don't know if you have our extension installed as well or not. We have a lot of things, and each time that I open something, there's something to introduce. See, we have in our extension, we have something. A lot of time in the streams, I see that people are asking that what was the rating of this problem? What was the rating of that problem? You can use Repovive extension, and with Repovive extension, it gives you the rating of the problem during the contest. During the contest, it will tell you what is the estimated rating of this problem. It might be plus minus 100 error. For example, let's see that's how was this prediction on this problem. You see that the rating is really 1600, so the prediction was accurate. During the contest, it tells you that what is the estimated rating of this problem. You can just get Repovive Chrome extension. If you just search, you can just see that. It also has dark mode on Codeforces and other things like that. If you want, you can take a look at it, and other things that we have AI coach that can help you solve the problem, give you hints, for example. That just doesn't work during the contest. We disable it during the contest. So yeah, I mean, that was also something interesting that you might use. Yeah, I mean, we have done many crazy things, and if I want to introduce all of them to you, I mean, I should have a full stream that talk only about this. Yeah, I mean, we just talk about the difficulty of the problems. I mean, we just estimated it, like how we also estimate the rating change. We estimate that's how your rating will change. We both estimate the rating of people and the rating of problems based on people who have accepted it. Okay, if you want to talk about this problem, tree cutting, let's read it and see how is it. You are given a tree with n vertices. Your task is to find the maximum number x, such that it is possible to remove exactly k edges from this tree in such a way that the size of each remaining connected component is at least x. Okay. Okay, we want to remove exactly k edges such that the size of each connected component is at least x. Is it really dp on tree? I see dp in the text, so probably. That looks like an interesting problem. Yeah, it can be solved with a dp. See, let me tell you how this problem can be solved. Let me solve it online in the topic stream. Guys, this can be solved. I mean, let's assume that I have some x and I have some k. Well, I've given this x, this k. I've given that how many edges I want to remove. Now the question is that what is the maximum x that we can have at the end? Let's do a binary search on this x and fix it. So now we have both x and k, we have it. We just want to see if it's possible or not. Then we can start a DFS and do that subtree DP again. We can just store the size of the subtrees, start from the leaves, with size 1 for the leaves. Let's just calculate the size of the subtrees. Whenever the size of a subtree became greater than or equal to x, so the DP part is where we calculate the size of the subtrees. This is the subtrees DP, where we calculate the size of subtrees. Now this is the greedy type. We say that whenever the size of a subtree got greater than or equal to x, this part can be separated. And it can be a part by itself, right? It can be a part by itself now. It can be disconnected from the rest, right? So in such a case, you can just remove this edge. That's the greedy part. Why? Because the things that are below it, they cannot be disconnected from their parent because their sizes are less than x. This one can be disconnected now because why continuing while it can be its own components now? You want to create another component later? Okay, you can just do it now and it won't be. It will be at least as good. So whenever it got greater or equal to x, just remove it and don't add the size of its subtree to its parent. That's the whole idea on this one. Is it clear? If anything is not clear, where was... If it's clear, please put a plus or use this 100 emoji. If you have time, code this also. Yeah, we can consider coding this as well, sure. One pass to reach a node, so how is it decided which has to use? Yeah, we will talk more about this. That's a very good question. We will talk more about this. If you want, we can maybe have the next topic stream on DP on DAX. But please, if you participate on that in advance, watch the topic streams that we had on graphs so that everyone know what DAG is, what the topological sort is, and we can just start talking. But we don't want to be in an infinite loop that keep repeating everything because in each topic stream, because that way we can never get to advanced topics. So that's super important that you first know the previous things and we can build on top of them, go to harder things. This is another problem. Okay, let's see. Okay, if you want, we can solve this problem too. Let me, for example, we can, and guys, we made some changes to our editor as well. This is, again, another one of hundreds or thousands of things that we have introduced. You can remove the header because it might be disturbing in this page as well. So let's talk about it. We are thinking about adding auto-completion in editor as well. Guys, let me code this one so that you can completely see everything I told you in this session in this code. And hopefully in the next topic stream, we will go to more advanced topics. I hope that in the next topic stream we won't have people who haven't watched this one and will come to the next one and then we have to repeat it. And we can actually go to more advanced things. Because if we keep repeating, as I said, we're gonna remain in the basics area and not going to more advanced things. So, okay, let me tell you about how the code would be. We basically have n up to 25. We have int of n and int of k. And we can have vector of int of g of n. So, and we have more than one query. So we can have int of t sin t while t minus minus. First of all, we sin n and k for int of I equal to 0, I less than n minus 1, I plus plus, int of u and v, sin u and v, u minus minus v minus minus, g of u dot pushback v, g of v dot pushback u. Now we have to calculate these subtree sizes. I will have an int of sub of n. I have them separated so that I can ensure that they are reset between the different scenarios. That's a very repetitive bug that I'm sure many of you have faced before. I have to start doing DFS from vertex 0. I'm doing it 0 base. As you see, I set u minus minus v minus minus. And I say void of DFS int of v. I keep in parent as well so that I won't go back to the parent. Now I say that for int of u, g of v, because I reset subtree size, in here, I don't need to reset it in anywhere else. In here, I first set subtree size equal to 1. And then I will go over children of u. If u, adjacent vertices of u, if u was equal to parents, I will continue. I will not go back to the parents. Then I will say dfs of u and v, its parent is v, and then I say sub of v plus equal to sub of u. I can call it DFS subtree because it's a DFS that calculates subtree. You see that's how we have some auto-completions now here as well. So this is basically how we calculate the subtree size. I hope that so far everything is nice. Advanced like what? More advanced problem, I mean harder problems. X is greater than n equal to k is impossible. Yeah, x greater than n over k is going to be impossible. That's right. But it doesn't change much because it just reduces log of n to log of n over k. Because we already have a log, that's might not be much change. But yeah, that's a good idea. That's right. Yeah, I mean, those are the very advanced topics like convex hull, etc. Now I will do a binary search. I say int of low equal to, for example, 0. In binary search, I always set low as something that is definitely possible and high as something that is definitely not possible. For example, n plus 1 is definitely not possible. 0 is definitely possible because always the size of each subtree is at least 0. And I say while high minus low was greater than 1, as long as they are not adjacent, I say int of mid equal to low plus high divided by 2. And this is my x, basically. Let's name it x. I want to now find the maximum number of subtrees that I can make if each subtree has size at least x. If that value was greater than or equal to k, that means that I can remove k edges. If it was greater than k, I just avoid removing some of the edges and I remove exactly k. Still, each subtree will be at least x. So I want to find out what is the maximum number of edges I can remove if each subtree will be x. So now I use DFS. I have DFS from vertex 0 to find this answer. I can, for example, keep either a global answer or I can return answer here in DFS of 0. Maybe returning might be better. So I have int of DFS, which returns that how many edges I can remove in here. It has int of v, int of par equal to -1 for int of u, g of v, if u was equal to par. Continue. This is the DFS part. DFS of u and v. Now I should just see that we have, it's better if, yeah, it's better if I combine these two. I mean, it's better if I remove this for now and this DFS subtree, and I calculate the subtrees in here. That works better. In here, I say sub of v equal to 1. You see why I changed it to this. In here, I will just say that first, int of result equal to DFS of u and v. I see that in there how many edges I can remove. And then I say that if sub of u was greater than x already, greater or equal to x, that can be its own component. So I can just say that I can in here say rest equal to 0 and say rest plus equal to DFS of u and v. And in this case, I can say just rest plus plus, remove this edge between v and u as well, because subtree of u already is greater or equal to x. Otherwise, I can just say that sub of v plus equal to sub of u. Otherwise, I just add it to this subtree. And this rest will be updated. At the end, I will return rest. And when I have this, I say if int of ans was greater than k, was greater or equal to k, then low equal to x, because this is x is possible, so I set low equal to x as high equal to x. And that's all. At the end, I should just see out low. This is the whole implementation. We can just see that how it works. I think like very, very advanced topics might come in the future. I've talked about most of these things in the previous videos or streams. I will put a blog on Repovive that you can ask me these questions and I will answer them. I do not recommend solving problems plus 200 or plus 300 of your rating. I recommend solving problems around your own rating, especially when you start, because the number of problems you solve are also important. It's not just about difficulty. The number is important too. You should solve a lot of problems. So it's good if you solve around your own rating and do not put too much time on problems at the beginning, because that might end up as a waste of time. I mean, not a waste of time, but it would be inefficient, you know. I really enjoy the way this editor is not working. Let me run this on the sample. I set sub of u greater than or equal to x, and I didn't pass x. So let me pass x. Oh, let me remove this. 0, -1, x. I have a runtime error. Let's see. Let's see where Oh, I didn't reset vectors. At the end, I should go from 0 to n, I plus plus. I mean, the problem is that previously, Codeforces did not have many test cases per problem. But now they're adding it, and that makes sense. I mean, we have it on Repovive as well. That helps them to test your code more efficiently. But anyway, it can have these bugs. So cat expected, the first one should be 2, but we are giving 3. So let's see that which other issues we have. The first one, let me also see it in here. The first case is this 1, 5. Okay, 1, 2. Okay. The first one is like this, and k is 1. 1 it should be removed. So the best answer is definitely 2. That's right. Okay, there's one more thing, and that is that if, see, what remains should also be a valid component. What remains? I mean, we didn't consider that what remains is also a valid component. That's the only thing that we should also consider. That's because that's very important. I can change this code to consider that as well. I can say that if sub of v was greater than or equal to x, just in here, res plus plus, and change sub of x, sub of v to 0, so that it doesn't pass anything to its parent. This way, for the root, it also considers that if this component is also a valid component. And this way, I'm calculating the number of components, not the number of edges. So I should compare ans minus 1 with k, or I should say that ans greater than k. This is how I can fix this. I hope that you understood that what the issue was. Now it gives a correct answer. Now I can submit to Codeforces. Compilation error. Why it was Python? Did I use Python, or is it a bug that we have? And the language is this. Let me test once again. Okay, it should be a bug that it turns into Python. Let me use C++. Yeah, it got accepted. So that's how this can be implemented. You can just see my last submission from here, and you're gonna have the code. I will recommend doing the 3-star topics on You Know Who Academy topics. Interesting. I haven't seen that, but thank you for the tip. Yeah, that's also something we can do. Yeah, let us know about any suggestions. And yeah, that's basically all. I hope that you understood the code as well. That's basically all that we wanted to cover in this topic stream. I hope that you got use from it and you learned something. If you want, in the next topic stream, we can move on to the more advanced topics in DP on graphs. And also let me know about any idea or any suggestion that you have about Repovive, and how, give me your feedback, what you are using, what are you not using much, what is working well, what is not working well. This list has almost every CPU topic. I think that maybe it didn't let you send the URL. I don't know why YouTube doesn't let you do that. If it was a link, just don't write it like a link. Maybe make some changes so that it's not like a link. For example, if it's in Codeforces, just put everything after codeforces.com, for example. Yeah, guys, let us know about how Repovive, how you feel about Repovive, how is it so far, and what you are using the most in it, roadmaps, contests, and do not forget to participate in our contests. Why I went to Codeforces. Do not forget to participate in our contests. That is going to happen this Sunday. The problems are really good. We worked on Judge as well and improved it. We are trying to get, we are improving everything, improving our servers, improving the code and efficiency optimizations to get the best experience for the next contest. This contest, especially one thing that is really good in it, the problems are really, really beautiful. I really recommend to you all to participate in our contest. I invite you all to that. The difficulty is like a global contest. It's like a Codeforces global contest. It's from easy problems to hard problems. So it's both helpful we intentionally designed it in a way that can be useful for both people who are newbie and people who are LGM. It starts from easy problems and go on. For harder problems, we have very interesting hard problems too. And we have interesting and beautiful easier problems too. Our initial problems, also we spent good time on them and had good problems. Oh, okay. Yeah. Let me... Ultimate topic list. Yeah, that's interesting. I like it. If you want to take a look at it, it's from You Know Who Academy. I don't know them, but you can take a look at it. Anything that is helpful for the community, that's really it. Okay. If you had any feedbacks, let me know. Also, this coupon code is gonna be available for the next 1 hour, around 1 hour. And you can use it to get the premium membership or the roadmaps. If everything is fine, if there are any questions, and also do not forget to either like us, and if you can, consider joining our channel so that we can actually improve the channel as well. We're gonna have more streamers soon on Repovive TV. Its name is not Repovive TV. We're gonna have more streamers soon. If you can, consider joining the channel. If you can't, even liking the video or subscribing to the channel, commenting under the topic stream. If you can, please consider that now that the topic stream is gonna end, please consider commenting on it right now. I think even right now you can comment. No, I don't know. I'm not sure if you can comment or not. But when it's finished, please consider commenting. These can really help us. If you can't join, these are going to be also great supports that can actually really help. Also adding flow, max flow, min cost, max flow, min cost. Okay, sure. Has Repovive its own rating system? Yes, Repovive has its own rating system. Right now, Omnic is in the first place. I'm sure you know who Omnic is. And Kson is in the second place. We had 2 contests. This is our 3rd contest, and our ratings is gonna go higher because it's the beginning. Every rating started from 0. So in the first contest, they are gonna go up, and the rating is gonna find its shape fully. Okay, guys, thank you for watching, and thank you for your supports. I hope that we can continue making what we provide better and better. And guys, our idea is to actually make a real change in the world. Anything, any parts, anywhere that we can be useful, whatever our expertise is, make a clear difference in that. That's what is important. That's what I personally work all day. I do not sleep and work, for example. I hope that we can do that. Definitely let us know about your feedbacks, how we can make it better. Let us know about it. Contest is like Codeforces or LeetCode type. The contest is more similar to Codeforces ones because LeetCode contests are not very good. I mean, let's be frank. LeetCode contests, the problems are, it's obvious that they put no time in designing their contests. I don't know. I mean, they either don't have enough people who can design good problems, very good problems, or something like that. But we made it such that anyone, for any purpose, either interviews or Olympiads or anything, they can get a high quality contest. That's super important. LeetCode is good, especially for people who are preparing for coding interviews. But it was mostly good before Repovive. Now that Repovive exists, I believe that LeetCode contests, because I think that they don't really have anyone in their team who actually is an expert in, for example, this field, like in competitive programming or things like that. And guys, an interesting news, Omnic is gonna do the solution discussion of our Repovive round after the contest. That's also something interesting that's gonna happen. Yeah, yeah, that's right. With dedication, everyone can definitely. With dedication, you can build something great, whatever that is. Okay, thank you guys for everything. I'm gonna see you soon in the either next content solution discussion or in the next topic stream. Thank you. Thank you. See you guys. See you. Bye.